Okay,
Is
so
the audio over here?
sorry, what was that, Gary?
Never mind.
All right,
Apparently
um,
the camera has a microphone.
I see. Okay, now there are two vectors. Great. So in here, right, here we have the problem. We have a table, and it represents a quadratic. The second vector, you may want to mute yourself, okay, so that it doesn't pick up on echoes. Thanks. All right, Christian's here too. Hello, Christian. So right now, I'm sharing my screen. There's a problem, and we're given a table. We're trying to figure out the equation for this table. Okay, never mind. It looks like he's gonna come in and out. So Alex, this is mainly for you, and also Victor's question related to vertex form, okay? Right now, I have highlighted 3 points, okay? I messed up on one of them. This is not special. This one is special though, okay? What's special about either of these 3 points? What do you know about them? Okay, you're thinking, maybe you're drawing a quick little graph in your head. You're thinking about where these 3 points are. So for this first one, maybe you drew a little graph, okay? -3 would be over here, and 0. Over here is +2 and 0. Then over down here, let's say, here's -6 and 0 for the x coordinate, right? Notice that for this table, we have this one being a y-intercept, and then the other two are your x-intercepts. And we can see based on where their zeros are, like for this problem, if x is 0, y has a value, that's when it crosses the y-axis. For these other two, both their y values are 0, so it's along the x-axis. These are the corresponding x values. Identifying that is going to be useful when we want to figure out the equation. So far we know that. We're going to focus on factored form, which generally looks like this, okay? X plus or minus something, and then X plus or minus something. This is factored form. And today's classwork focuses on the A value up here, solving for that. So if you were here yesterday, we talked about that, but today we slow down and go into how do we solve for this A value and what it could mean for the equation. So if we know those are our intercepts, just like it says up here, we want to reverse our understanding of the zero product property. So what does that mean? We started with something in standard form. It looks like this, bx plus c, okay, that's standard form. Oops. Plus c, standard form. And when we factored it, we got this thing, factored form. Now we're thinking about, can we go the other way? Can we come up with factored form first and then do some things to it to figure out standard form? So knowing the x-intercepts, this is what it means to reverse it. We can work backwards. Y equals a, x, and if we know our x value is 3, we need to add on +3 in order to make that equal to 0. So that means my next part, if this value is 2, what do I need to do to 2 to get it to make 0? And anyone can answer this part. Yeah, you need to minus, as Victor said, right? We have to take away, and more specifically, we have to take away 2. So in factored form, we're almost there, but now we have to deal with this thing, the a value. And now we have some flexibility because we know these points that I'm dotting on, right? All these points are points along my parabola. So if I were to sketch some more of these, -2, -4 is over here. 1, -6 is here, okay? and then 1, 4, it's over here. We know all these points are on your parabola, so on and so forth. Okay, and it'll look something like, in yellow, like this. And then it comes up. Okay, something like that. And it's that A value that lets us narrow down and figure out what exactly my equation is. We have to do something clever to solve for it. So let's use a point we know is on the parabola. So oops, not sure what happened there. Let that go away. Okay, any point that's on the parabola. For now, we can choose, like, let's use a point. We could use the y-intercept. So that's 0, -6. That's an x and a y value. And we're using this stuff to solve for a. So -6 equals a times 0 plus 3 times 0 minus 2. We see that a is 3 times -2. -6 equals a times -6, right? A here has to equal +1. So factored form, we know for sure, is this thing. Okay. And then if you want a standard form equation, you'll FOIL like that. Okay, you draw the arrows. We get y equals this bunch of stuff. And we can combine like terms to get our final answer. Okay. Now, Victor asked the question for how do we get vertex form out of this, right? We have a lot of information in here from the table, and you notice in my little graph, okay, over here, that my vertex isn't something that's actually given, right? We do have the y-intercept, but that's a little bit higher, right? It's not exactly my vertex. So where my red dot is on the parabola, that's my vertex. Let's try to figure out the vertex, so then we can transform standard form, okay? Oops, switch back to my pen. Standard form into vertex form, okay? Vertex form or graphing form. That's the third form for a quadratic. Sometimes it's useful depending on the information that is given. So in order to do that, we'll focus on the graph representation. Let me change colors, okay? You know that right in between here, wherever your, well, green's probably not the best color. Wherever your vertex is, it creates an axis of symmetry. Okay, that's like a midline or a folding line. Okay, that's if you fold this yellow parabola along this line, it's mirrored, all the points match up. This blue thing, right, is your vertex. We're looking for that. One of the special properties of like symmetry or this axis is that the distance, like from here to here, from here to here, all those distances are the same, which we can make use of. Okay, it's symmetric, it's mirrored. So previously, we just focused on the x-intercepts. We thought about, okay, if I start at -3 and go to +2, how much distance is that total? Right? You think, okay, do some subtraction, it's a total of 5 units, right? So going from here to here is a total of 5 units, which means to get from one x-intercept to your axis of symmetry is 2.5. So now you know the x-coordinate of your vertex, right? Or your axis of symmetry. Those two things, it's in common. You know that right here, right? X has to equal negative 0.5. So far, so good? So our lesson, this classwork, uses that like idea again and again. And there's a shortcut you can take with this. And I'll go over that later. I've mentioned it before. When you have something in standard form, like you do here, negative b over 2a equals axis of symmetry. But it's that same idea. It's the middle. And in the table, it comes up in a pretty neat way. If you notice, like, these points, right? You can see these points being repeated on your parabola. So you start at 0, you go to -4, you go down to -6, and then you switch, and then you see it get repeated again. -6, -4, 0, here's a 6, so look, there's another 6, right? So when I look at the table, I can see that, oh, right there where I change, like I'm decreasing, 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 and suddenly I start increasing over here, I know that my vertex or my minimum, or wherever that special point is, the vertex, it's hiding in between these two values. How much is it hiding? Well, it's halfway between these two guys, which is the same as halfway between these 2 points, which is the same as halfway between these 2 points, okay? So far, so good? Okay. So we know the x coordinate now, and it's nice because we have this equation, okay? Now we can figure out where the y coordinate is. And you should expect it to be a little bit more negative than -6, okay? So it's probably like -7 maybe, or some kind of decimal value in between. From there, you can work with what we're given. And now we can solve for, so you know that x equals 0.5. Don't forget the negative, okay? What's the y coordinate equal for the vertex? So now we can use one of these equations. We can use this one. So if you know that x over there is 0.5, let's solve for y. 0.5 squared plus 1/2 minus 6. Let me double check. Yeah, it is negative. Yeah, negative 1/2. Is it a little more than 6? Why does it seem a little bit off? Oh, yeah, it's a little bit more than 6. So let's do the math. It's kind of tiny. Let me zoom in a little bit. Okay, so that's 0.25. This one's 1/2. And then you subtract 6. You add this stuff together, you know the y coordinate is 0.65. All of it is, wait, no, hold on. I messed up my sign somewhere. Why am I getting something that's off? Did I draw something wrong? Okay, I expected something a little bit more than -6, but my math doesn't add up right. Something's weird. Where's my mistake? Okay. So 1/2, 1/4, 1/2. I'm getting negative 5.25. That doesn't seem right. Any ideas, guys, on where I messed up? It's negative 1/2. Yeah, that's right. Oh, I see what you mean. Thanks, Victor. Yeah, you found, I gotcha. This one's a minus, right? There we go. Good catch, good catch. Okay, so if we do that, now it makes sense. Back to blue, y equals a little bit more than 6. 6 and 1/4. Right, there we go. So we're going this way, so it can fit on the same page. So now you know that for the vertex, the vertex is at negative 0.5, like Victor said. And now we correctly see it's a little bit more than 6. Okay. Let's turn it into vertex form. So that looks like this fancy equation, where h comma k is vertex. So we'll start plugging things in. This a value over here is the same as your a value from all the other forms. So we just know it's positive 1. X, okay, since h here is negative 0.5, subtracting a negative is like adding a positive, squared, and then minus 6.5. That's vertex form. All right. You'll get lots of practice with vertex form in the coming chapter when we learn how to complete the square. That's the more conventional way to change something from standard form into vertex form. But here, we're just making use of the graph, making use of the table, making use of that property of symmetry here, okay? That's what chapter 8 is teaching us. And then later, we will complete the square. And that's in your Orange Merrill textbook. And you'll see it again in Algebra 2, right? Part 2, ready? So if you ever need me to slow down too, or like don't move the screen, just let me know in chat, and then I'll pause it there. So for this one, I think it ends up being a little bit nicer with where the vertex is. Yeah. So this one, it should be a little bit faster. Let's go through the equation again. For this one, we are looking for the intercepts. That's the current way we know how to do things to figure out factored form. The ones that repeat, which isn't always the case, you won't always have 2 x-intercepts. Sometimes you'll have 1, sometimes you'll have none. In this case, we do have 2 x-intercepts. They are here and here. And that leaves the y-intercept over here. Factored form looks like plus something x plus something else. So again, we go through the motions. If x were negative 5, and together we need this whole term to equal 5, we have to add on that. Yep, very good. Victor, do you want to write the next one since you're already there? What's the other form? What's the other thing that goes into the blank over here? Yep, if x were positive 1, as you see up there, then this missing thing has to be negative 1. Very good. Minus 1. And just to confirm, we need to see if this a value is in fact positive 1, because sometimes it's not. You remember from our classwork from like before that if you know your intercepts, here's 5, here's negative 1, that's not enough information to get one specific parabola. It could look like, woo, like that. It could look like this, right? It could be really narrow, so on and so forth, right? And all those parabolas have those 2 same x-intercepts, but they have different a values. Yeah, and then what Gary drew in, that could also work. So that's why, just to be safe, we got to check. And I want you to get used to that process. Last year when I taught it, I didn't emphasize this enough. And thus, it really confused my students. And later on, when we complete the square, that also is what ends up being complicated. Oops. Okay, oops. A little bit too much there. So let's confirm. And Victor asked earlier, does it matter which point you use? No, it doesn't matter which one. But the y-intercept is nice because any math that has to deal with 0 is like easy. You know, anything times 0 is 0. So it just saves you some work if you know your y-intercept. But we could choose any point over here. You could choose like this one, but those are larger numbers that I probably can't do in my head. So it just is for efficiency's sake. That's okay, Gary. You get extra attention. So, I mean, we could choose this point, right? And just to demonstrate to see that it works, let's use negative 8 comma well, -1, comma 8. Okay, doesn't have to be y-intercept. So y is -8 equals a -1 plus 5, -1 plus -1. -8 equals a times +4, and over here we have -2. Yep, looks like a ends up being +1 again. So in factored form, since a is +1, you can rewrite it looking like this. All right. If you foil, if you draw your arrows, or if you draw your boxes like this, you can turn it into standard form. That's just multiplying everything out. Okay, so then we have standard form, x squared plus 4x minus 5. And then the new part, vertex, right? Vertex form, where is the vertex? So we got to make use of our table. In this case, it's that same idea. It's halfway between your two x-intercepts. You can think from here, one's at -5, the other x-intercept's at 1. That's a total of 6 units. So let's hop on over 3 times. 1, 2, 3. Okay, and it should work the other way too. If from my other x-intercept, hop over 1, 2, 3. So this thing is your vertex. This was already given to us in the table. That wasn't the case before. So that's looking just at the x-coordinates. You can see that pattern in the y-coordinates. Notice it's decreasing, decreasing, getting smaller, getting smaller, getting smaller, and then suddenly it starts to go back up. And then you see these points are being mirrored. Okay? So that means this point has to be your vertex. From the table, we see the symmetry, right? We see that halfway in between the x-coordinates. So the vertex is -2, -9. So for vertex form, let's put in those numbers. Y equals, a is just 1. And then anyone want to fill in these other parts? What goes there? So use your annotation tool. You can write it onto the screen. This is the harder part about vertex form. What should go there? Okay, Victor's gotten start. And what about the y coordinate, Victor? Well, thank you. Yep, you need that. Great, -9. So there's a tiny mistake present in Victor's work. Does anyone see it? Yeah, Raymond's got it out. So Victor, you actually gave me the vertex form for a parabola that has +2 for the x-coordinate and -9 for the y-coordinate. So you see how Gary added in the plus? You have to be careful with this opposite idea, okay? Because when you plug in, when you take away a -2, it becomes adding 2. Yeah, that's the weird part, right? It's that same idea for when you filled in like the factored form. It's very similar. So I'm just going to write that in. So it's plus, oh, let me go change my pen color. This one's +2. This one's -9. Okay, so that's vertex form for the second problem. Yeah, because it's your first time seeing it. Of course we're going to make mistakes. We're going to learn from them. So here's a hint, right, about our like tip rather than a hit, right? If you want to keep stuff straight, right? I would write y equals 1, x minus -2 squared, and then plus -9. And then you simplify, And that helps you avoid that mistake, right? Y equals x minus a negative. Now we see it has to be +2. Adding a negative, -9, like that. That's how I would use the formula. Right. So for this part, these problems may be a little bit faster. So we're focusing on vertex form or factored form again. So if you know your graph like we did from here, this is going back to the water balloon task we graphed in the very beginning of chapter 8 when school was still in session. Looks like this, okay? And right now, what do you think B and C represent? Alex, do you want to type it in? The other two, everyone else is already in the session from before. Gary's giving you a little hint. Yeah, those are the x-intercepts. And it seems kind of weird right now because you're thinking, okay, it's adding B and adding C, right? But if you notice and you look at your problem as what Gary pointed out, right? If you add 0, okay, that's fine. That looks like the x-intercept. And over here, if you add 8, you're like, wait, that's not the x-intercept. If I'm adding 8, then shouldn't the x-intercept be -8? Right? Something's a little weird. And hopefully we'll shed light on like why that is. B and C do in fact represent x-intercepts. Okay, so then you notice like that problem comes up over here, right? They do minus, and it's that a value that yet again appears and kind of fixes things for us to have things be consistent, right? We know that because the x-intercepts here are 0 and -8, our equation should look like this. And you'll see an a value here that is not +1. In order to get the parabola to flip over, it has to be like negative something. Let's see what it is. So here, how could you use this graph to figure out the value of a? Any ideas, Alex? You're solving for a. Yeah, let's use a point. So in this graph, there's lots of different points we can see, but because of the axes, we may be a little bit off. Let's go ahead and maybe use this one up here, right? That one's very clear. It's at 4, 32, but any of the points on the parabola would have worked. So great answer, Alex, you're absolutely right. And now we can solve for our a value. Let's just leave it in factored form. You don't always have to expand it, so I'm rewriting the equation down here. Okay, using a point on parabola. Okay, we're using 4, 32. 32, x and y, equals a, 4 minus 0, 0 minus 8. 32 equals a times 4, -8. Oh, something a little different this time. A times -32. Did I mess up somewhere? Oh, you're right. Yes, thanks, Gary. Good catch. I was writing a bit too fast. These things are 4. You're right, you're right. Thank you for that. -4. So then you have -16 here. And you'll see you have an a value when you divide both sides by -16, something different. A here has to equal -2. So for factored form, you have -2 times x minus 0, x minus 8. And since you're taking away 0, maybe you could delete out this part. That stuff's optional. So then it just becomes, oops, like that. Maybe you want to leave it in so it's extra obvious that your x-intercept was 0. That's also cool. Standard form, we can multiply this stuff out. For me, I like to take care of this part first. So that's x squared minus 8x. And then I consider the a value. Negative 2x squared plus 16x. Okay, this thing is standard form. And we can practice one more time. Okay, based on the graph, what's the equation for the vertex form? Someone want to write it in? You can go down the screen, Victor. It's cool. Lag. Okay, 2 laggy. Okay, so I'll just write it in then. For this problem, since you already know the vertex, it's just applying and putting it into the equation. So for us, vertex form, it's very easy when we know the vertex. Okay, y equals x minus 4 squared plus 32. Does that look right? Did I forget something? Yeah, so it looks right. Let me zoom back up to the general vertex form over here. I'm not missing anything? A. Very good, Alex. I am missing the A value. Right, Gary, very good. So be very careful here, because right now my equation actually looks more like this. It's a parabola that actually opens upwards. That's a little bit wider than the current parabola, right? So don't forget about that A value. Okay, previously it was all ending up being +1, and it didn't matter, like that. But in this case, it does. Okay, there should be a -2 out here. And so that -2 is the same as this -2 and then this -2. Okay, that's your A value. So don't forget it, because it throws off your equations. And you'll get more practice with it. But you see why I overemphasize this A. Solve for A, double check that first term in your quadratic. Okay. Session 2. And then we have parts D and E, and this is the last portion. We now have a different problem. So in part D, we have a Al throwing a water balloon. Let's try to figure out the equation of this through like given a word problem in the beginning. So here are my axes. Okay. He releases the balloon from the 10-yard line. It landed at the 16-yard line. If the ball had a height of 27 yards, what is the equation that represents the path of his toss? Well, let's draw a little picture. Let's call this one 10. Let's call 16 maybe over here, 16. Arcs like that. Oop. And then somewhere here, you know that the y coordinate is 27. Okay. And I can be even more specific. I can write down the points like that. And then for here, we don't know the x-coordinate of our vertex just yet. Any ideas on how we could figure out the x-coordinate of our vertex? Yes, very good. Line of symmetry. You know that it has to be going down here. I have a total units of a 6. 6 cut in half is 3. So that means this point right here has to be 13. Okay, 13 comma 27. And now we can kind of cheat. We can go straight to vertex form. We can ignore factored form, and we have our equation. So y equals, well, not quite. We still have the a value to deal with, right? Not so much taking a shortcut just yet with factored form or vertex form. We still got to solve for a. So I'll present it a little bit differently. If we go to vertex form, it says we wanted more practice with that, right? So far, we can plug in minus 13 squared plus 27. So using vertex form, I think this way ends up having a bit more work. But still same idea, right? Maybe on the side, we can say using factored form. And you can see which one's easier for you. Still got to use a point. Got to use another point on parabola. In this case, we can use the x-intercept. Let's use an x-intercept. 10 comma 0. So 0 equals a 10 minus 13 squared plus 27. 0 equals a negative 3 squared is 9 plus 27. So what does your a value have to be? Do some division, right? A has to be negative 3. So your factored form equation, or your vertex form equation, will look like negative 3. Oh, that's a really ugly 3. Negative 3 times x minus 13 squared plus 27. All right. And we can do the same for factored form. That's just like the same stuff we've been doing before. X minus 10, x minus 16. Plug in vertex. And since I run out of room, you can take my word for it that it does give you a similar equation, and you can mess with it to get vertex form. Okay? Is it cool for me to move on? Yeah. Alex, so far so good, yeah? Because it's different than my first video that I posted. Our focus this time around was vertex form. Oh, I used too much space. Okay, let me add in another page. So for this second part, we focus on the table that's here, okay? I'm gonna cut it. So we're looking at part E, okay? Since it basically gave us a table, and we're trying to figure out the equation based on this specific table, and there's something funny there. Okay, because previously we could rely on solving, like using the x-intercepts to figure it out. This is part E. But in this case, if we notice, okay, there's a special point. Oh, shoot. We only have one x-intercept. What can we do to figure out and get more information to come up with an equation? And Alex, since these other guys stayed around for a little while, like you can ignore what Gary's writing so far, but how would you like think about what we could do? You can use Gary's hint. What do you think he's trying to hint at? What's the question? So in part E, you have a table. And right now, there is only one x-intercept. How could you make use of this table to figure out the equation for the quadratic? That's the question. Yeah, you can use the line of symmetry again. And so if you look at the numbers, you can see them decreasing, and suddenly they start increasing again. And so you have that mirrored part. It kind of starts over here, and then it gets cut off. So you can see why Gary added in like 16, 9, and 0. So then we can see, oh, there's my other x-intercept. So that means this down the middle has to be our vertex. And maybe just for practice, we'll focus on vertex form. I'm sure you can figure out factored form on your own, or when I post these notes, you can look at part 1 over here. I go over factored form to, wait, no, not here. Session 1, right? I go over factored form for that. Wait, is that it? No. Session 1 over here, okay? But for our practice, let's do vertex form, just to make it a little bit different. Oh no, Gary, your markings. Okay, I'll add them back in. So we have, okay, extend the table like that. There's 10, 11, and 12, 0, 9, 16. That means this thing is your axes of symmetry. This whole thing is your vertex. Practicing vertex form, y equals a x minus h squared plus k. Y equals ax minus 7 squared plus 24. And so choose a point. Which point do you want to use to solve for a? Okay, I'm going to save some work. I like smaller numbers. I also like 0, 2, comma 0, because it saves us work. Right? There's small numbers, there's 0 in it. You could choose any of the other numbers like before. Okay, so that's your x, that's your y. 0 equals a 2 minus 7 squared plus 24. 0 equals a negative 5 squared plus 24. Did I do that right? No, I messed up. Thanks. I see it, I see it. This thing. 5, 5, 5. Thanks. Okay. So a times 25 plus 25. Okay, a has to equal -1. Y equals -1 times x minus 7 squared plus 25. Vertex form equation. So that's it. Cool. I'm glad you were able to join us today, Alex. A little bit different practice, Raymond, Victor, and Gary. I hope you got some more practice from seeing it twice, a little bit different. I hope the second session you got something out of it too. Thank you for your participation. For tomorrow, Alex, okay, you had some options on what I wanted to talk about. And tomorrow, based on who is, like, I might just do one session tomorrow. You may want to just watch, well, I don't know if I'm going to record it, so maybe I'll, okay, in the chat, tomorrow will be less math focused, okay? You have these options. You want me to talk about math courses at Lowell? You want me to talk more of like Algebra 1 stuff? Do you want me to go over other classes? Because we don't have like Arena just yet because we are in shelter in place. We're not at school. But around this time, you would put in course selection for your sophomore year, thinking about what classes you would take. That's number 3. I can talk about that and the process. I can also talk about generally like the high school requirements in California, what's required of you. And then 4, if you want to hear about other things, like I can also advise on that because I went to Lowell not too long ago and I can advise, okay? So you want 3, most of your classmates also chose 3. So that's tomorrow's like lecture. It's more of like an advising session. And if you have specific questions, you can email me those and I can like tailor whatever I have to say to those questions, all right? No, that's all. Take care, Alex. See you, Gary. Bye, Victor. Bye, Raymond. Thanks for joining me twice. Appreciate it. Bye.